Hi, this is problem 3 from the 2020 AIME 1. A positive integer n has base 11 representation ABC and base 8 representation 1BCA, where A, B, and C represent not necessarily distinct digits. Find the least n expressed in base 10. Okay, so we have this first number in base 11, and we have this second number in base 8. So let's express n in terms of the usual powers of the base. So in the case of base 11, we'll have that n is equal to a times 11 squared plus b times 11 plus c. So that's one way to write n. And for the base 8 representation, we'll have 1 times 8 cubed, 512, plus b times 8 squared, plus c times 8, plus a. So that's another way to represent n. Now we don't know what n is, so let's subtract these two equations to eliminate n. So subtracting and rearranging just a little bit, get b53, c7 is equal to a 120 minus 512. So we have a single integer equation in 3 variables. Now this would be very difficult to solve in general, but we're not trying to solve for a general solution. We're trying to find the minimum value of n that satisfies this. And we also have that these variables are digits in a base 8 number. So there's quite a few restrictions on these variables. They all have to fall within the range of 0 to 7. And in fact, a shows up as a leading digit, so it can't even be 0. It has to be at least 1. Okay, so that makes things quite a bit simpler. So since we're trying to search for the minimum value of n, it makes sense to begin our search with the minimum value of a. But we notice that if we choose a to be too small, then the right side of this equation becomes negative, which then forces one of the variables b or c to also be negative, and that's not allowed. So a has to be at least 5 to make the right side of this equation positive. So we have a greater than or equal to 5. And again, since we're trying to find the minimum value of n, it makes sense to start our search with the minimum value of a. So let's start our search with an a of 5. So plugging a of 5 into this equation, we get b53, c7, 88. Here again, let's begin our search with the minimum value of b to minimize n. So let's try b equals 0, c7 is equal to 88, but 88 doesn't divide evenly by 7, so that's not a valid solution. Let's try b equal 1. We have c7 is 35, c is equal to 5, so that is a valid solution. So the valid solution that minimizes n is c equal 5, b is equal to 1, a is equal to 5. Using the first equation, we can calculate n to be 5 times 121, 1 times 11, plus 5, 605, plus 16, 621. Final answer.